Okay, Trig, we're at the last section of the chapter, which is geometric sequences. This is typically a little bit harder to understand. It's not too bad until we get to I don't know, maybe like example 5 here. This is where it gets a little bit tricky. So just kind of follow along, and homework assignment is page 63, 2 through 34 evens, and 38 if you need to write that down. So we've talked about arithmetic sequences before and said that arithmetic sequences are where you're adding and subtracting the same number every time. A geometric sequence is where you are multiplying by the same number each time, okay? And we've talked about this before about like technically you're only ever multiplying, you're not ever dividing, but because if you are, let's say like you're dividing by 2, that's the same thing as multiplying by 1/2, okay? So they won't ever have you divide, they'll just have you multiply by that in fraction form, okay? And in a geometric sequence, kind of like when we had an arithmetic sequence, we had a common difference, which we labeled as D. This one will have a common ratio, which we'll label as R, okay? And that'll be what we're multiplying by every time. Okay, so first example is just saying, is it geometric? If it is, what is the ratio? What's the value of R? And then write each sequence as a recursive function. Okay, recursive was had to do with the use of n-1. So we'll get to that part. But in part A, we're going from 3 to 9 to 27 to 81, etc. And what I'm doing is I'm multiplying by 3 every time. Okay, so that's not too bad. So this is, yes, this is a geometric sequence. R is going to be 3. And then what we're doing for our recursive formula is that any term, you take the 1 right before it, which is u sub n-1, and we multiply that number by 3. And I'm going to put 3 out in front. Okay. Sometimes they'll even forget, like they'll forget about that multiplication symbol, and they'll just say u sub n equals 3 u sub n-1. They just will put them right next to each other. Okay. So the recursive formula is really just u sub n equals r, whatever our r is, times u sub n-1. It's saying the 1 right before it, take it times that r value. Okay, in this case it was 3. Okay, so whatever term right before, we take it times 3 to get the next term. Okay, in B, we're going from 5/2 to 5/4 to 5/8 to 5/16. And so I'm notice that this bottom number is being multiplied by 2, but really what's happening is that the whole thing, like the first number, is getting multiplied by 1/2. 5/2 times 1/2 will give me 5/4. If I take that times 1/2, that will also be 5/8. If I take that times 1/2, that will be 5/16, etc. So this is another yes, and the r value is 1/2. So we're not dividing by 2, we're multiplying by 1/2. And our recursive sequence is u sub n equals, it's that r value, which is 1/2 times u sub n-1. So it's just saying the term right before it, I take it times 1/2 to get the next term. That's what that recursive formula is saying. Now, again, recursive formulas are okay, except if I want to know u sub n, I have to know u sub n-1. Like if I want to know the 20th term, I would have to know the 19th term. But then I would have to know the 18th term and the 17th term and every single term right before that. I couldn't just plug the number in. That's with an explicit formula, okay? So we'll get to that, but recursive for right now, that's what he will look like. At the end of this chat, like when we start to review next week for this chapter, we will have a note card that has these recursive and explicit formulas put on it. So you won't have to memorize those. You'll have to know what to do, but you won't have to remember those, okay? So example 2, find the common ratio of the geometric sequence where the first term is 2 and the second term is 8. Okay, now they only give me 2 terms. So if they said that this was an arithmetic sequence, like I was adding something each time, I would say you're adding 6. But they don't tell me that. They tell me it's geometric. So in this case, I know I'm multiplying by something to get from 2 to 8. And that has to be times 4. So if they tell me it's a geometric sequence, I know I'm multiplying, and I'm taking this one times 4, so r is 4. It says list the first 5 terms of the sequence and write the sequence as a recursive function. Okay, whew, we got a lot of work to do. U sub 1 is 2, u sub 2 is 8. Okay, u sub 3 is taking that number times 4 again, so that's 32. the fourth term and the fifth term, first 5 terms. 32 times 4 is 128. And then 128 times 4, I gotta think. I just multiply it out. I don't have a calculator. 2, 3, 1, 1, 512. I should have known that, maybe. 512. Okay, those are the first 5 terms. And then our u sub n, or any term, is going to be 4 multiplied by the 1 right before it, which is u sub n minus 1. Okay, if I'm going too fast, please pause or go back or do whatever you need to do. And then we're going to graph this function. So we're going to go as 1 is a value of 2, 2 is a value of 8, so 2, 4, something like that. 3 is a value of 32, and I'm like already off the chart. It's going to go and do something like this. Okay, and we've talked about before how this almost kind of looks linear, but it's not, because it's so steep. 4 is a fairly large number that you're multiplying by. And so when that happens, this is really an exponential function. So like it's missing this little curvy part on this side, and it's exponentially growing really, really super fast because it's being multiplied by 4. So geometric sequences look like exponential functions. And you're going to see in the explicit formula that we do have an exponent in there. So I'll show you when that time comes, okay? All right, so write a geometric sequence in explicit form. Oh, it's coming now. Here we go. This one is saying our recursive sequence is defined by u sub n equals 2 u sub n minus 1. So what that means is that we're multiplying by 2 each time. Our r value is 2. So I'm doubling each number. So if I'm starting with u sub 1, I'm starting with 7. Okay, let's just list out the first couple terms. They say listing the first 7 terms. We can probably get away with just doing like the first maybe 4 terms, right? So the first one, u sub 1, is 7. And u sub 2, I'm going to write out like how we get u sub 2. U sub 2 is taking 7 times 2, right? And so u sub 2 is going to be 14. Now u sub 3 is taking that number times 2. Or really, I'm going to write it out as 7 times 2 times 2. We're just multiplying it by an additional 2, right? And that's going to be 28, okay? Then u sub 4 is taking 28 times 2, or really starting with 7 times 2 times 2 times 2. I'm just multiplying that number by an additional value of 2. And that's going to be 56. Let me do one more. U sub 5 is 56 times 2, which is really just 7 times 2 times 2 times 2 times 2, 4 times, right? I'm just multiplying by an additional value of 2. And that is going to be, what, like 112, I think, is what u sub 5 is, okay? So here's the deal. What I notice is that each time I'm doing this, if we look at this little pattern going on here, the first time, when we were looking for the first term, we were taking 7 and just multiplying by nothing, really. The second time, we were multiplying by 2 one time, right? The third time, we were multiplying by 2, but twice. So that would be another way of saying that is like 2 to the second power. When we were finding the fourth term, we were multiplying by 2 to the third power, right? And when we're doing the fifth time, we're multiplying by 2 to the fourth power. We're multiplying by 2 4 times, which is 2 to the fourth power. So I can already kind of see this explicit formula, especially if I look at this one, is that like u sub 5, okay, is written as 7 times 2 to the fourth power. But if I represent that as like n's and n minus 1s, I would say u sub n is equal to 7, which was our first term, u sub 1, times our r value, which was 2, to the n minus 1 power. Okay, now let me talk through that because that was really confusing. Okay, u sub 1 is our number here, and I am multiplying that by the r value, a total of, if I'm doing the fifth term, I'm multiplying it 4 times. So I'm multiplying it 1 less than the term that I'm talking about, right? Okay, I'm multiplying by that r value 1 less time than the term that I'm just like the term that I'm on, right? If it's a fifth term, I'm only multiplying by 2 4 times. Okay, it's kind of like how we have n minus 1 in the arithmetic sequence formula. So this is the explicit formula for anything, right? They have it right here, except they don't put this dot in the middle. They just write it as u sub 1 times r to the n minus 1. So if you need to write that bigger, u sub n equals u sub 1 times r to the n minus 1 power. And the really nice thing about explicit always, as opposed to recursive, which was up here, is that all I need to do, like if I wanted to find the 100th term of this sequence, right, it's probably going to be a really big number, but if I wanted to find the 100th term, all I would have to do is plug in the first term and then plug 100 in for n, and I'm done, right? I wouldn't have to know the 99th term and the 98th term, etc., right, like I would with recursive, okay? So that's a really nice thing. This is the explicit formula for the geometric sequence, okay? All right, example 4. Write the explicit form of a geometric sequence where the first two terms are 2 and negative 2/5. Okay, so u sub 1 is 2, and u sub 2 is negative 2/5. Okay, so I have to be multiplying by something to get from 2 to negative 2/5. Okay, how do I get from 2 to negative 2/5, okay? And some of you guys can figure this out, but it is, I'm multiplying by negative 1/5, right? 2 times 1/5 is going to be negative 2/5, right? Or 2 times negative 1/5 is negative 2/5, okay? You can actually figure that out also if you take negative 2/5 and divide by 2, all right? Dividing by 2 is the same thing as multiplying. If I keep flip him to the top, multiplying by 1/2, it will be negative 1/5 is what you are multiplying by, okay? So you can divide this guy by this guy to figure out what your ratio is. Kind of like up here, if we didn't know that we were multiplying by 4, we could have taken 8 and divided by 2 to figure out that that was 4. We can take the second term and divide by the first term, negative 2/5 divided by 2 to get negative 1/5, okay? So hopefully that made sense. Our R value is negative 1/5. Okay, and then find the first 5 terms of the sequence, but we needed the explicit formula. Okay, so let's go ahead and do the first 5 terms of the sequence. We have u sub 1 is 2. We have u sub 2 is negative 2/5. Okay, if I multiply that guy again by a negative 1/5, it's just going to change my bottom number. So u sub 3 is going to be a positive 2 over 25. Then if I multiply by a negative 1/5 again, our u sub 4 is going to be negative. It's like alternating back and forth, positive, negative, positive, negative. And it's going to be 2 over 125. And if I find u sub 5, which is the last one that we need to do, I multiply him by negative 1/5 again, and that's going to be positive 2 over, I think that's 625. So, you know, we're just keep multiplying and multiplying each time to figure out the next term of the sequence, okay? Our explicit formula is u sub n equals u sub 1 times r to the n minus 1 power. So if we just plop our stuff in, the u sub 1 was 2 times r, which is negative 1/5. And I'm putting that in parentheses because it's negative and I don't want it to look like you're subtracting. And this is my explicit formula that I have for doing that, okay? So hopefully this is making sense. If I'm going too fast, please pause and go back or ask somebody else that is understanding. This is kind of how this works, okay? All right, the next one. This is the doozy. This is going to be the hard part, if it wasn't hard already, all right? They give us the 4th and the 9th term of the sequence, okay? The 4th term of the sequence, they say, is 20, okay? I'm going to write that out as u sub 4 equals 20, okay? And then I'm going to say that u sub 9 equals negative 640, okay? All right, now I'm going to write this as a weird way. Normally we say u sub n is equal to u sub 1 times r to the n minus 1 power, right? Okay, so the u sub 4, which would be our 4th term of the sequence, we know that this term is actually 20, right? And we don't know what u sub 1 is, so we're gonna leave that as u sub 1, and we're trying to solve for r as well. But n minus 1 would be 1 less than the term that I'm looking for, so this would be to the 3rd power. Okay, so we have 20 equals u sub 1 times r to the 3rd power. That's how we can write this piece out. It's kind of a weird way, okay? We're going to do the same thing for the ninth term. So u sub n, or my ninth term, is negative 640. I'm going to substitute that in that spot, okay? And then u sub 1, this will be r to the n minus 1. If we're talking about the ninth term, will be 8. Okay, and then I'm going to do this. Okay, this is the missing piece here, and this is the confusing part, is that I'm going to take this guy, negative 640 equals u sub 1 r to the 8th power, and I'm going to divide those guys by this stuff, which is 20, and u sub 1 r to the 3rd power. Okay, so this is the weird part. You put the last term over top of the first term, and you make it into a fraction. Okay, we've done this before. We did this before when we were doing arithmetic sequences, when we had like the 4th and the 9th term. But in arithmetic sequence, your common difference is like a slope. So you could just do the y2 minus y1 over x2 minus x1. This one, you're multiplying by something each time. So we have to divide. Which is what we're doing here. We're making it into a fraction. We're dividing to figure out what that ratio is, what that common ratio is, okay? All right, so here we have this stuff going on. My u sub 1s can cancel out because like those are the same top and bottom. And then r to the 8th power divided by r to the 3rd power is really r to the 5th power. You're just subtracting those, right? And that's equal to negative 640 divided by 20 is negative 32, okay? And then to find r, I take the 5th root, right? The 5th root of that, and r is going to be the 5th root of negative 32 is negative 2. So our r value is negative 2, so we're multiplying by negative 2 each time, okay? If you wanted to check that, you could start with this guy. The 4th term is 20. So we go 20. If I multiply by negative 2, that's negative 40. I multiply by negative 2, that's positive 80. I multiply by 2, that is negative 160. I multiply by 2, that's positive 320. And I multiply by 2 again, that's negative 640. So this is the 4th term, 5th term, 6th term, 7th term, 8th term, 9th term. It checks out because that's what negative 640 is. Okay, so that checks out. It says find the explicit form of the sequence. Oh boy. Okay, all right, so we know that r is negative 2. This is a doozy. And then I need to find u sub 1 for my explicit formula. So I'm just going to go backwards, okay? If I'm multiplying by negative 2, I'm going to divide by negative 2 to go backwards, right? U sub 3, if I take 20 and divide by negative 2, that's going to be negative 10. If I divide by negative 2 again, that's going to be positive 5. And if I divide by negative 2 again, that's going to be negative 2.5, okay? Now, if I work frontwards, this times negative 2 is 5, this times negative 2 is negative 10, this times negative 2 is positive 20, etc., right? So our u sub 1 for sure is negative 2.5, okay? Again, I'm going kind of fast, so if you're having trouble catching up, just pause and think about it for a second, okay? Or ask me on Monday and I will clear up any confusion, okay? Or try to at least. So then your explicit form, again, the explicit is u sub n equals u sub 1 times r to the n minus 1 power. So all we do is plug stuff in. U sub n is negative 2.5 times negative 2 to the n minus 1. And this is your explicit formula, okay? All right, we will do example 6. We'll just skip example 7 because we're running long, okay? But then we have the partial sums again. Don't worry about this part of the formula because that's how you could compute the partial sum the long way. We're just going to type it into our calculator, but we have to get to this point right here. We have to get to that spot, okay? So find the partial sum. This tells me that u sub 1 is negative 3/2. Or negative 1.5, okay? This is the 2nd term, 3rd term, 4th term, 5th term, 6, 7, 8, 9. So this is u sub 9, okay? So we know that u sub 1 is negative 3/2, and then we have to figure out what we're multiplying by each time, okay? So I am alternating from negative to positive to negative to positive to negative. So I know that my r has to have a negative in it in order for it to change sign each time. And I'm going from 3/2 to 3/4 to 3/8. So again, I'm multiplying that bottom number by 2 or I'm taking the whole thing times 1/2, times 1/2, times 1/2. So my R value is negative 1/2. Okay, and what they're wanting us to do is find the partial sum, and we did this in the arithmetic sequences where we're adding those terms together. Okay, and we're adding the first term to the second, to the third, to the fourth, all the way up through the 9th term. So if I write this as a sum, I'm going from the first term to the 9th term, and then I am writing out in this spot or in the parentheses what my explicit formula is, which is u sub 1 times r to the n minus 1 power. Okay, u sub 1 is negative 3 over 2, and I'm going to take that times negative 1/2 to the n minus 1 power. Okay, this is going to be a little tricky, and I can't really show you on here because I'm on my iPad, but plugging this into the calculator, you have to be very, very, very careful of your parentheses. You have to be very, very, very careful of your fractions so that you have those correct. You have to be very careful of this being an exponent, and you have to be very careful that these are negatives and not minus signs. Okay, so these should be negatives. This should be a minus sign. That's so weird. It's very finicky. Okay, so I will do it on my calculator on here, and you can't see this because I am on my iPad, so I'm going to try my best, and I will come up with an answer, and you see if you can come up with the answer as well. And if you do, you help the rest of the people around the room get to that answer, because I am sure that somebody has a question. Okay, so I'm going to do negative 3 over 2, open parentheses, whoa, see, and it's already causing me problems. It's already causing me problems. Parentheses, negative 1/2, oh shoot, negative 1/2, this is causing me so many problems already. Okay, parentheses to the n or x minus, I wrote n minus 1, this should be x minus 1 power. X minus 1 power. Okay, I think I am all the way through. Yes, I think I am all the way through. And I hit enter, and it takes me forever to, like, it took a calculator a second to like actually figure it out. It is negative 513 over 512, so just slightly over 1. That's like 1.000001 as a decimal. Okay, that's what he will end up looking like. That is the 9th. This is a partial sum, but this is the 9th partial sum because we are doing the terms 1 through 9. Okay, if you got 513 over 512, you're awesome. Go help somebody else who did not get that far, because when you type this in, you have to be very, very, very careful, especially with all the fractiony and things and everything going on there. Okay, all right, that was a lot. I will clear up any confusion, or at least try to, on Monday, but go ahead and start that homework assignment if you can, and at least do the stuff that you do understand, and we will reconvene on Monday.